Okay, students, today we're going to be working with section 2324, slope and right linear equations. First of all, talking about slope. You can see this car is driving up a hill here. That road has a certain slope to it, and the way we measure slope is usually the rise compared to the horizontal distance. This is also called the run. So the variable we use for slope is m. So I'd say my slope of this grade here, this road, would be m equals rise over run, comparing the rise to run. The vertical distance, the change in the y, over the horizontal distance, the change in the x. Okay, so we said this was slope is our m. The way we're going to find slope is this. Given two ordered pair of points, x sub 1 and y sub 1, x sub 2 and y sub 2. One way you can find slope is this. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. A common phrase you'll hear me say is this. It's basically you take the y values and subtract them or change. This is the Greek symbol delta, which means change. Change in y over change in x. And basically, it's just this formula right here. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll be using that in a minute. Two lines that have the same slope here. You can see they never intersect, so those are parallel lines. These two lines do intersect. They actually intersect, you can see, at a 90-degree angle. We call these perpendicular. Perpendicular lines have slopes that are what we call opposite the reciprocal. So let's say this first line here had a slope of, I don't know, 1. This line would also have a slope of 1. They have the same slope. That's just the opposite for perpendicular lines. Just to throw something out there, I'll say one of these lines, like this one right here, let's say the slope was 2/3. A line that would be perpendicular to it, first of all, would have opposite, and we're talking about positive, negative there. So if the first line is slope is positive, the 2/3 is positive, this slope line would be negative right here. And reciprocals. Perpendicular lines have slopes that are opposite the reciprocal of each other. The reciprocal of 2/3 is 3/2. These two slopes right here are slopes of perpendicular lines because they're opposite the reciprocal of each other. There's basically 4 kinds of lines when you're looking at them. First of all, right here, this line is going up as it goes to the right, so it has a positive slope. This line is going down, you can see, as it goes to the right, so it has a negative slope. So we have a lot of lines with positive and negative slope. Then we have this. This is a horizontal line right here, so it has a slope of 0. There is no slope, I guess you would say. And this one, going straight up and down. This slope is undefined because you cannot divide by 0. If you define the slope between -2 and 3 and -2 and 2, -2, you'd get some number over 0, and you can't divide by 0, and that's why vertical lines have an undefined slope. Oh, let's go back a minute here. So, using this little formula here, m equals, it's basically change in y over change in x. We're going to find the slopes of lines that pass through -1, 4 and 1, -2. And I usually write it like this: m equals change in y, it's just this right here, over change in x, which is just subtracting the x values. So first of all, on top of the y values, I have -2 and 4, so I'm going to say -2 minus 4 all over. Now we started with the -2 for the y, so we got to start with the 1, the x value of this coordinate for the x. 1 minus -1. Just got to be careful with your negatives. -2 minus 4 is -6. And 1 minus a -1, well, that's plus a positive. That's going to give me 2. So you could write your slope if you reduce it as -3 over 1, but -3 is fine. Okay, over here. M equals change in y over change in x. There's one y value, there's the other y value. 2 minus 2, all over. 3 minus -3. Careful with your negatives. 2 minus 2 is 0. Minus a negative is plus a positive. That's all over 6. So 0 divided by 6 is just 0. So the slope of my line is 0. This is a horizontal line because it has a slope of 0. Graphing the line with the given conditions. Okay. Well, a couple things. Slope is rise over run. We know that. So we're going to use that when we graph using the slope. First thing we do, if it has a slope of 1/2 and passes through the points 2, -1, graph your point. Over 2 and down -1 right there. There's my point. Then we'll use the slope 1/2. From that point, we're going to go up 1 and over 1, 2 to this point right here. You can do it as many times as you want. Up 1 over 1, 2. Also, if your slope is 1/2, that's the same as -1 over -2, because a negative divided by a negative is a positive. It's still going to be 1/2. So I can go back to that original point and go down 1 and back a -2. Down 1 and back a -2. And there's my nice straight line. I can do the same thing over here. Graphing the point -3, -4. -1, 2, 3 right here, and then down 1, 2, 3, -4. The slope is -3. That's the same as -3 over 1. So I can go down 3, -1, 2, 3. That's my rise, and over a +1. -3 over 1 is the same as 3 over -1. No matter what, if one of them is one of your numerator or denominator is positive and the other one's negative, when you divide, you're going to get a negative slope. So I can go up 3 also. 1, 2, 3, and back a -1. And there's our line. Rate of change measures how much a quantity changes on average relative to another quantity, often time. So first problem here, use the table that shows the temperature at different times of the day. You can see here time and temp. Now, when you're going to work this, it's kind of like slope. Time here is your independent variable. And then the temperature would be your dependent variable because your temperature depends on the time. So this is kind of like my x values up here, and these are my y values down here. Because rate of change is kind of like slope. You do the y values on top, difference in y values on top, and the difference of the x values on the bottom. So it says this: what was the average rate of change of the temperatures from 8 a.m. to 10 a.m.? From 8 a.m. to 10 a.m. right here. Well, if you looked at them like ordered pairs, it would be 8 a.m. to 36 the temp, and 10 a.m. to 47 the temp. So rate of change is basically like change in y over change in x. I'd say this is 47 minus 36 all over 10 minus 8, which is going to give me 11 over 2, or 5.5. Now, 5.5 degrees per hour. 5.5 degrees per hour. What is the average rate of change of the temperature from 12 p.m. to 4 p.m.? Okay, 12 p.m. to 4 p.m. My y values are basically the 60 and the 55, so I'd say 60 minus 55 all over. Now 12 p.m. to 4 p.m., that's 4 hours. So you can't really say 4 minus 12. That would give you a negative 8. You got to kind of use some common sense here and say, well, from 12 to 2 is 2 hours, and from 2 to 4 is another 2 hours. This is basically 4, or 4 minus 0. That would be your change in time. So I'm going to end up with 5 all over 4, or 1.25 degrees per hour. And then right here, during what 2-hour period was the average rate of change of the temperature the least? Well, I'd say from 12 p.m. to 4 p.m. Because the rate of change was smaller. It was 1.25 degrees compared to 5.5 degrees. Okay, Kevin's savings account balance changed from $1,140 in January to $1,450 in April. Find the average rate of change. Time is your independent variable. So your months are going to be your X, and your money are going to be like your Y. That's your dependent variable. Time is always your independent variable X. So the average rate of change here. First of all, the money amounts on top, that's your Y's. 1450 minus 1140 all over, well, January to April. January, February, March, April. That's 4 months. So I'm going to put a 4 there. Subtracting these, you should get 310 over 4. And 310 divided by 4 is $77.50. What does that mean? The average rate of change is $77.50 per month. So he added $77.50 to his savings account per month. That's the average. Okay, here. Slope-intercept form of a line, a linear equation. You can see this line, then I got this little box here. Y equals mx plus b. Well, what that means is m is your slope, and b is my y-intercept. We're going to write some linear equations here, and we're probably going to get into this tomorrow, so I'm going to end this right now. We'll see you guys on the flip side.